In a previous video, we found the derivative of a function, f of x equals x squared, at a particular point. And in this video, we're going to find the general derivative, or the derivative function of the function f of x equals x squared minus 2x. And we're not going to do it at a particular point, okay? And so we're going to use the limit definition that looks like this. The limit as h approaches 0 of f of x plus h minus f of x all over h. And recall when we did that previous problem, the limit definition looked like the limit as h approaches 0 of f of a plus h minus f of a all over h. All right, so let's go ahead and get started. We want to find f prime of x. Again, that means the derivative. And it's going to be equal to the limit as h approaches 0 of f of x plus h. Remember, f of x plus h means you take what's there and you plug it in to the function wherever there's an x. All right, so we're going to have x plus h, quantity squared, minus 2 times x plus h, and then minus f of x, and f of x is this entire thing. So minus, and I like to put a parenthesis there so that I don't forget to distribute my negative sign, because that leads us to errors, and that's all over h. Okay, so let's keep simplifying now. The limit as h approaches 0, and we have to use the FOIL method to multiply this out, so we get x squared plus 2xh plus h squared. That's this thing multiplied out. Minus, I'm going to distribute the negative 2 with the x and the h, so minus 2x minus 2h. And now I'm going to distribute the negative sign here with x squared, and then negative minus 2x is going to become positive 2x, and that's all over h. And now let's combine like terms. So we get the limit as h approaches 0 of x squared, and there's a negative x squared, and so those cancel each other out. We get a negative 2x and a positive 2x. Those cancel each other out. And I think that's all we can cancel out. So we have 2xh plus h squared minus 2h, and that's all over h. If I were to plug h equals 0 in at this point, try solving this limit through direct substitution, I would get 0 over 0, and that's indeterminate. So let's go ahead instead and factor an h out. So the limit as h approaches 0, and I'm going to factor an h out. So I get 2x plus h minus 2 all over h. And then notice we can cancel those, and then we can take the limit as h approaches 0. So if we did that, we would get 2x minus 2. So f prime of x is equal to 2x minus 2. This is the derivative function. And notice if we wanted to then find the derivative at x equals 1, or at any point, all we have to do is plug 1 into the derivative function. So we would get 2 times 1 minus 2, and that would give us 0. That means the derivative of that function at 1, or the slope of the tangent line at 1, is going to be 0. If I wanted to find f prime of 2, I would take 2 times 2 minus 2, and that would be 4 minus 2 is 2. So the slope of the tangent line to that function at 2 is going to be 2, and so on. We can find it at any x value that we want. So finding the general derivative is actually a nice thing to be able to do, because then we can find the slope of the tangent line at any point we want.